Hello, and today we're looking at the importance of conserving biodiversity. So, what we're going to look at to start with is some of the things that we get from having a biodiverse world around us, such as things like resources, new food species, biomimetics, medicines, physiological research, and pest control species. Historically, humans have been really dependent upon having really biodiverse ecosystems around us. We used to exploit thousands of different species of plant and animal at different times of the year to sustain us. As we have become more sedentary and developed our agricultural systems, the number of species that we exploit has diminished. But it does not mean that we still do not rely upon the natural biome around us to provide additional resources that we cannot replicate using our technology or something similar. So the first one we're looking at is resources that we directly exploit from the environment, and these can be divided into things like wood, and this is for used in building furniture or structures, fibers. These are for making things like cloth or rope, so things like cotton would be an example. We have things like oils, and these are vegetable and animal oils that are used for things like lubrication or soaps or food, or as a fuel indirectly as something like lamp. So there we go, fuels. So things like for burning, so we can burn wood. Charcoal is an incredibly important fuel source in a lot of the world. Vegetable oils or alcohols can all be used. And finally, food. So we can directly exploit things like plants, animals, fungi. The next resource we're going to look at then is new food species. So, like I said before, we only use a relatively few species in agriculture. So we basically just tomatoes, potatoes, corn, wheat, those sort of things. And as we have used them, we have moved them to areas where they're not so good at coping with pests, diseases. As we have bred them, we have reduced their genetic diversity, so they're less able to cope with diseases. We've moved them to areas that are not so good for them to grow. And what we can do is look to the environment for new species to exploit because they are better adapted. So find new wild species to cultivate that are better adapted to conditions. Okay, so there's lots of examples of this. You can sort of Google them, but a few of them are things like potato bean, which is good for areas in North America, and it has high protein. So that could be used for something like an animal feed potentially. Marama bean. This is from Southern Africa and it's drought resistant. So it can cope with drought, but it's got high protein beans, a bit like soya. You can grow or find species that are salt resistant or tolerant, which means they can cope with those conditions. So things like spinach is a good example of this. It can cope. Some varieties of spinach can cope with high salt content, and therefore you can grow them in areas where poor irrigation practice has caused soil salinization. And you got some examples of animals that are used for this as well. Things like cane rats. Reproduce rapidly, can cope with different conditions, local conditions, so they're better adapted than traditional livestock for things like that. Next one then is biomimetics. So biomimetics is exploiting evolution to improve our own products. What does this mean? Well, evolution, animals have been evolving for millions of years through a process of trial and error, so that the final designs that we see now, their features are really finely attuned for efficiency or whatever effect they're looking to achieve, and we can copy that, and that helps improve our designs. So examples of this include things like vehicle design, things like the wingtips of an eagle. They can produce efficient wing designs. So you will have seen winglets on the end of airplane wings, and they follow a similar sort of thing. Humpback whales. They have really efficient flippers, so this can be used for things like propeller design or ship rudders. And shark skin has very low resistance through the water because of the way that they're designed. So this has been copied for things like swimsuits and ship coatings, saving us energy. Another area that we can copy is for architecture. So things like termite mounds have this really incredible ventilation system. So a termite mound will have like a central passage that's connected to the outside wall from the bottom and the top. So these are like these massive termite mounds that you see scattered in grasslands. You have cool air enter from the bottom, work its way through the colony, and then out through the chimney at the top. So you've got stale air passively removed, so it doesn't take additional energy to do this. And we can copy that in some of our building designs so that we are using less energy to extract stale air from our buildings, or we can copy structural features from plants and animals so that our internal bracing and struts are very strong. Adhesion is another one. So adhesion is important. So things like gecko toes are very good adhering to all surfaces without needing glue, so we can copy that. Burrs on seeds have given us Velcro. And things like lily pad and water plants like lotus are water repellent. So we can copy those features as well. And the other one is materials, things like spider web. If we can synthetically copy that, then we'll have extremely strong, lightweight materials for things like car airbags or body armor, things like that.